All right, so to end this unit, we're going to be talking about isosceles triangles. So we know that isosceles triangle is a triangle with two congruent angles and two congruent sides. So we call the vertex angle the angle that's not congruent. So if there are three angles inside of a triangle, two of which are congruent, the third is what we call the vertex angle. And the two sides of that vertex angle are going to be the congruent side, are the congruent sides. And these two congruent angles, we call them the base angles. So just a little bit of vocabulary to go through and be more clear with. Now, there is this, it's the isosceles triangle theorem. And what it says is if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if I have these two as my base angles, then that means that the congruent sides are going to be opposite, meaning directly across from them. So that means if angle C is a base angle, then side AB here is going to be one of the congruent sides, and the side opposite of angle A is side BC, and that's going to be another congruent side. So that's all this is saying, and actually that's how we've been looking at and defining isosceles triangles. Now there's also the converse, which is just looking at the same theorem, just in reverse. So it says that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So is that the reverse? Oh, sorry. So the isosceles triangle theorem is saying these two angles are congruent, so the opposite angles are going to be the base angles. Whereas the converse goes into the reverse. So it's saying if these two angles are congruent, then the sides opposite are congruent. Really, if you are using this in a proof, these can be easily confused, as you just saw. So I wouldn't expect you to state the isosceles triangle theorem or the converse of the isosceles triangle theorem. Just say the isosceles triangle theorem, and that should cover whichever one you mean. You don't have to be specific and say the converse. So just bear that in mind, and when you're writing out a proof or working with any of these, you can just say the isosceles triangle theorem. So let's look at some examples here. These are non-proof examples. We have a nice little picture off to the side, and it says that if segment RV is congruent to segment RT, then I should be able to name two congruent angles. So RV is here, and RT is here. Well, if I look, that actually makes this big triangle, RTV. So if these two sides are congruent, then these must be the congruent angles. So that is angle RVT is congruent to angle RTU. RVT and RTU or RTV, doesn't matter. And that's all we can say, because this triangle here and this triangle there, we don't know that those angles are congruent, so that doesn't help us. All right, next up we have if RS is congruent to SV, so RS and SV, notice if I connect those two, I get this triangle. So now, if these are my congruent sides, my congruent angles must be VRS, and that is congruent to SVR. Notice I'm writing these angles as three letters just to be more specific. I can't say angle V because there are two angles at that point. So just watch out for that. All right, if angle SRT, so SRT is there, is congruent to STR, is there, name two congruent segments. Well, that makes this little triangle there. If I could draw in straight lines, it would be helpful. So that means that segment RS is congruent to segment TS. And finally, I have STV. So STV is congruent to SVT, and that's this little isosceles triangle. So that means that we are going to have angle VS, or sorry, side VS is congruent to side TS. All right. So just using this triangle or isosceles triangle theorem, basically a definition of an isosceles triangle to go through these problems. Okay, all right, some more problems here, more application driven. So triangles GHM and HJM are isosceles with GH is congruent to MH and HJ is congruent to MJ. Triangle KLM is equilateral and triangle HMK is 50 degrees. So we want to find each measure. So there's a lot here, a lot of overlapping triangles. So we're going to look at each picture differently based off of what question is being asked. So here, KLM. So I want to find angle KML. There we go. Angle KML. Well, looking at this, I know that KLM, triangle KLM, that's why I was confused. KLM is equilateral, so that means that each angle is congruent. More specifically, each angle there is 60. So the measure of angle KML is 60. Looking at angle HMG now, so HMG, looking there. Well, I know that triangle GHM is isosceles. So that means that these two angles equal each other. Now, what else do I have? HMK, which is this angle, is 50. See that? HMK is 50. Well, I already found this angle to be 60. So that means that these two together make 110 degrees, and they're supplementary with this angle, HMG. So that is going to be 180 minus 110, which is 70. And GHM is going to be the vertex angle. So if this is 70, that means that this angle is also 70. So GHM must be equal to 40. Lots of crazy work there, but if you take your time and go through it, it does make sense. All right, and angle HJM is 145 degrees. So HJM, find MHJ. MHJ, so this angle here. Well, we're already told that this is an isosceles triangle. So these two angles must equal each other. So here what we have is that 145 plus those two angles, so if that's x and that's x, and so plus 2x, is equal to 180 degrees, then 2x must be equal to 35, right? Because 180 minus 145 is 35. So x is equal to 17.5, so this is equal to 17.5. Using similar logic, we can go through and look at the next problem, which says if angle G is 67 degrees, so that's 67, ignoring the previous work, we want to find GHM. Well, we know, yet again, this is an isosceles triangle. So if this is x, we know 67 plus 67 plus x is equal to 180. Well, 67 plus 67 is 134. So if we subtract 134 from 180, we are going to get 46. So that means that this is equal to 46. These can be difficult, so just make sure you take them very, very carefully, take them slowly, and if you need to, draw the picture, write out multiple pictures. If you're trying to do this in your head, if there's no work, if you're not marking up a picture, redrawing diagrams, you can't be surprised if you get confused. But notice, as I went through this picture, I wrote on this. Now, if you're in my class, you feel free to use a whiteboard or whatever, but it's going to benefit you if you write this out on a piece of paper in your notebooks or whatever. All right, and then we have one final proof to end this. So if we look at this, look at my statements and my reasons. I'm going to start with my given. So we know that DE is parallel to BC, and angle 1 is congruent to angle 2. So angle 1 is congruent to angle 2. We want to prove that AB is congruent to AC. Well, if I look at this, DE is parallel to CB. So that means that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Why? Well, when lines are parallel, corresponding angles are congruent. Remember that theorem? The trusted theorem we've had before? Whenever we see parallel lines, we know it's probably going to be one of those angles, and here's corresponding angles. Well, if 1 is equal to 2, which we already know, and 1 is also equal to 4, and 2 is equal to 3, we can say here that angle 4 is congruent to angle 3, and that's just substitution. Well, then that means that triangle ABC is isosceles, because two congruent angles make this an isosceles triangle. So that is the, well, we can say definition of isosceles triangle. Because the next step is what we're trying to prove, and that is AB is congruent to AC, and that is the isosceles triangle theorem. So if I go all the way back here, we looked at the isosceles triangle, which says if the sides are congruent, then the angles are congruent. Well, the converse says if the angles are congruent, the sides are congruent. So actually this is the converse, but if you want to just skip that in your proof, I'm okay with that. Other teachers may not be, but luckily you have me. So that's the proof. So really use your parallel lines to show that angles are congruent, and then once you have that these base angles are congruent, you can say it's an isosceles triangle, and the logic goes out from there. So hopefully these proofs aren't as bad as some of the proofs we've had this unit. But this is the last section here, so make sure you're feeling good with this material as we go into the test.